Dear students, welcome again to the class of business mathematics, and we are in the same topic today. This is part 3 of break-even analysis, and in our last class I have discussed 5 problems. Today I am going to discuss another 3 problems. So this is problem 6, and in this problem a company has a linear cost function and has determined that over the next 3 months, so that all data given in this problem is for the next 3 months, it can produce 1000 units at a total cost of $300,000. This same manufacturer can produce 2000 units at a total cost of $400,000. The units sell for $180,000 each. So in this problem, if you compare the previous 5 problems, there is a difference. In this problem, you are given a small p. This is selling price per unit. However, for the total cost function, they did not directly given here the C, fixed cost, and M, which is variable cost per unit. Instead, you are given 2 points or 2 condition. In the first data, it says 100 units, 1000 units at a total cost of $300,000. So this one you need to consider as x1, and this one will be your y1. However, in this problem they said you need to use q for the number of units. So instead of x1, it's better to write q1 for this one, and this second occasion it should be q2 and it should be y2. So now we can calculate our cost function by using this formula. We know y minus y1 is equal m into q minus q1. So in order to calculate cost equation, you first need to calculate m. So m equal to what? y2 minus y1 divided by x2 minus x1. These things we discussed before in our previous classes. So y2 is 400,000 and y1 300,000. So it will be 100,000. y2 minus y1 will be 100,000 and x2 minus x1 will be 1000. So this equal 100. M equal 100. Therefore, y minus y1, which is 300,000 or 3 lakhs, is equal m into q minus q1, which is 1000. So this implies y equal 100q minus 1 lakh plus 3 lakhs. So your cost function will be y equal 100q plus 2 lakhs or 200,000. So this one will be your cost function, and the revenue function, this is your cost function. The revenue function we know R, which is equal price times quantity. Quantity is Q here. So price per unit is 180. 180Q is your revenue function. In functional form, you can write it in this way: R as a function of Q, which is 100Q. So now you know your revenue function and you know your cost function. This is your revenue function, and you can in this sheet I have chosen the second formula. Directly you can use 2 points in this formula, then you can also calculate the cost equation or cost function. That will be exactly same what we found here, y equal 100Q plus 200,000. So this is our cost function, and this is our revenue function. So we can calculate profit function, profit function, revenue minus cost. And cost function, since we denote by y here, so it's better to use y instead of c. So the profit function will be this one, 80Q minus 200,000. And now what is the second part of this question? B. What is the fixed cost? And I know fixed cost will be the y-intercept in the cost function. So the fixed cost will be $200,000. And what is marginal cost? This one also the coefficient of Q in the cost function, which is 100. $100 is the marginal cost. And find the break-even quantity. For the break-even quantity, we know profit equal to 0. We need to equate profit equal to 0 and profit function 80Q minus 200,000. So we can replace this. Then after simplification, our Q will be 2500. So 2500 units is the break-even quantity. And what else? Find the break-even dollar volume of sales. It means what is revenue at the break-even. So if you put break-even quantity in the revenue function, then you will get break-even dollar volume of sales, which is $450,000. And the break-even chart, let me show you quickly here. Already we discussed break-even chart in our previous lecture elaborately. So let me just show you here break-even chart for this problem. And this is our y-axis, and r-axis, this is the number of units, and break-even quantity 2500. So let's say 2500 is here, and break-even point will be x coordinate will be this, y coordinate will be 450,000. So let's say 450,000 is here. X coordinate 2500 and y coordinate 450,000. And the y-intercept in the cost function is 200,000. So the cost function will start from here. If this distance is 400,000, then 200,000 will be probably this. So your cost function now you can draw. You can now draw your cost function. This is your cost function. And revenue function will initiate from the origin. So from this place you can draw your revenue function, and that one will passes through the break-even point. So this is your cost line, this one is your cost line, and this one is your revenue line, and they will intersect each other at break-even point. And the coordinate of this point is 0, 200,000. And what else? This is the loss region, and this region is the profit region. And other one, sometimes you need to show the cost line, fixed cost line. So which will start from this point, and it will be parallel to the q-axis. So this line is known as fixed cost line. So this is your break-even chart. Now let us try to understand the next problem. A company has a linear total cost function and has determined that over the next 3 months it can produce 10,000 units at a total cost of this. So this one will be exactly same. This is Q1, this one is your Y1, and this one will be Q2, and this one is Y2, and this is a small p. So you can calculate a revenue function that will be RQ is equal 5.5Q price times quantity, and cost function you will calculate like before. First you need to find M, that is Y2 minus Y1, which is 6 lakhs minus 5 lakhs 50,000. So it will be 50,000 divided by 20,000 minus 10,000, which is 10,000, which is equal to 5. Therefore, in order to find cost function, that will be Y minus Y1 equal M into Q minus Q1. So this implies Y minus Y1 is 550,000, which is M into Q minus Q1, which is 10,000, and this implies Y equal 5Q minus 50,000 plus 5 lakhs 50,000. This implies Y equal 5Q plus 5 lakhs. So Y equal to 5Q, 5 plus 5 lakhs is your cost function, this one, and revenue function 5.5Q. So by subtracting cost from revenue, it should be Y here. You will calculate your profit function. So this is your profit function, and by using this function you can calculate the break-even quantity. Now for the fixed cost, this is the fixed cost, and marginal cost will be $5. So what else? We need to calculate fixed cost, marginal cost, and break-even quantity, and break-even dollar volume of sales. So break-even quantity, for the break-even quantity we need to put profit equal to 0, and that gives us Q equal 10 lakhs. So 10 lakhs is the break-even quantity, 10 lakh units, and break-even dollar volume of sales it means revenue at the break-even, which is 55 lakhs. So the break-even point will be 10 lakhs, comma 10 lakhs and 55 lakhs. This is the break-even point that we will show in the break-even chart. And F, what is F? It says construct the break-even chart, label the cost for line, revenue line, and fixed cost line, and break-even point. So that we already construct here in this sheet. So you see the break-even chart is this one, and break-even point, first you need to identify 10 lakhs and 55 lakhs, and if it is 55 lakhs this distance, then cost line will initiates from 5 lakhs because y-intercept or fixed cost is C. So cost line will initiates from this point and it passes through the break-even point, therefore this is your cost line, and revenue line will start from the origin and passes through the break-even point, so this is your revenue line, and the line parallel to the q-axis starting from this point is the fixed cost line, and this point is the break-even point. And G it says what would be the company's cost if it decided to shut down operation for the next 3 months. And 3 months comes from where? Because all data given here is for the next 3 months. So if company shut down its operation, then company will be in loss of fixed cost. If company shut down its operation, then still he need to pay the fixed cost. So for the next 3 months, the fixed cost will be the total loss of the company. It is 500,000 or 5 lakhs. So company without operation, the cost with no operation is equal to fixed cost, and which is 500,000. And the last one is H. So if because of a strike the most the company can produce is 100,000 units, should it shut down? If it required to shut down, then why or why not? You need to explain it. So you see here, company without operation, the company is in loss of 5 lakhs dollar. But if somehow because of a strike company can produce 100,000 units, so it's a positive sign. Why the company needs to shut down? It's not, because 100,000 units will make a backup for your total loss. 5,000 500,000 is the total loss without operation. So if company can produce 100,000 units, then what will be the profit? If you put 100,000 units here, then the profit will be what? You see, if Q equal to 100,000, then profit will be this amount, and this is company is still in loss of 400, since the profit is negative. So the company still is in loss of $450,000, but company without operation the loss is $500,000. So which one is better? Of course this one is better. So company should not shut down its operation, because the loss with no operation is 5 lakhs. But with this, during a strike, company can produce this amount of product, which indicates a loss of this. So the company should not shut down its operation, because this loss is less than the fixed cost, which is the total cost without operation. So company should not shut down its operation, because this loss is less than the fixed cost of $500,000. Or you can explain these things by your own language, it's not a problem. Most importantly, company without operation and company with this units of operation is better, because the loss is going to minimize 50,000, which is 50,000 less than the total loss of company without operation. So now let us try to understand our last problem in this part. A company has a linear total cost function and has determined that over the next 3 months it can produce these units at a total cost of this amount. So this one will be your Q1, and this is exactly same like what we did before. This one will be your Y1, and this one will be Q2, this one will be Y2, and this is the selling price per unit, which we denote by a small p. Now we need to determine the revenue function, cost function, and profit function using Q for the number of units. So the revenue function will be 13.25 price into quantity, 13.25 into Q, it makes sense. And cost function. Cost function, we need to use this formula, y minus y1 equal m into q minus q1, and here m equal y2 minus y1. y2, which is 296,000 and 224,000. So let me write it here, 296,000 minus 224,000 divided by q2 minus q1, 18,000 minus 12,000. So this one will be 6,000 in the denominator, and in the numerator it will be 72,000, so which is equal to 12. Therefore y minus y1 is 224,000, which is equal 12 into q minus q1, and q1 means 12,000. This implies y equal 12q minus 144,000 plus 224,000. So this implies y equal 12q plus 80,000, and this is your cost function. So you know revenue function and you know cost function. Now you can calculate your profit function by using this formula, P equal R minus Y, and that will be this one. And in B, you need to know the fixed cost. You need to note the fixed cost, and fixed cost will be the y-intercept in the cost equation. So this is the fixed cost, $80,000, and the marginal cost is the coefficient of Q in the cost function, which is $12. And what is the break-even quantity? In order to find the break-even quantity, you need to equate this equal to 0. Profit function equal to 0 gives us 1.25q minus 80,000, which is 0. Therefore q equal 80,000 divided by 1.25, so 64,000 units will be your break-even quantity. And now the next one, what is break-even dollar volume of sales? If you put 64,000 in the revenue function, then you will get break-even dollar volume of sales, that is this. So the break-even point in the break-even chart will be 64,000 comma 848,000. This one will be your break-even point. And the next one, F, what will be the profit if company shut down its operation? The company if shut down its operation, then 80,000 will be loss. $80,000 will be the loss. The total loss, profit will be minus 80,000, which indicates the loss of 80,000. And if because of a strike the company will be able to produce only 10,000 units, should it shut down for the next 3 months? Why or why not? Of course not, because company can produce these units because of a strike, so it will minimize the total loss without operation. And we already found that total loss without operation is this amount, $80,000. But if company produces 10,000 units, then the profit will be this amount. In the profit function, if you put 10,000 in the profit function, then the total profit will be negative 67,500, which indicates a loss of $67,500. So the company should not shut down its operation because the loss decreases from $80,000 to $67,500. So you can try to sketch the break-even chart by yourself, but let me show you quickly. The break-even point, I said 64,000 is the break-even quantity, and this is the y coordinate or r coordinate, which is break-even dollar volume of sales. So 848,000, if we just put this point here, you don't need to be so serious in order to know where this point is. It's just it is just a rough sketch. So you first identify the break-even quantity 64,000, then just consider a point in this area and put the coordinate of the point. Then you should check where the cost line initiates. Cost line initiates from 80,000, since y-intercept is 80,000. So this one, the coordinate of this point is this, and the revenue line will start from the origin. So the break-even chart is very simple. You just need to put the break-even point first, then revenue line will passes through the break-even point, and cost line will initiates from this point and passes through the break-even point. And this is the fixed cost line. It will start from this point and which will perpendicular to the q-axis. And that's it. So thank you very much for listening, and hope you enjoy the lecture, and hope to see you in our next topic. And next topic will be piecewise linear function. We will explain some application of piecewise linear function in our next lecture. Thank you very much.